So it'll change the duty cycle of that 5-volt output to raise and lower the intensity of that LED. I had to change the frequency of that. I was playing with that output on various things earlier, but it was at a default of around 800 hertz or 900 hertz or something like that. So I was able to change it with this code here. So it's default for pin 5 and 6 is 976. And I first tried 62 kilohertz, but my little cheap scope had a hard time reading that, so I put it on 7.8 kilohertz, which is right here. So you do that in the void setup section. And here I just have it froze. You can see that's about what I'm getting, about 8 kilohertz. And this little scope here is just hooked up to the digital out pins and pin and ground. Same thing that's driving this LED. So, say if I unpause it actually. So this is the signal that the Arduino output is giving me, and it looks a lot cleaner at the lower frequencies, but it still comes through. So you can see I'm changing the duty cycle all the way down from a very almost hard to read spike right around there. It gets a little easier for this scope to read, but you can see the frequency remains the same, the voltage remains the same, and that's voltage is the drop after that resistor right there. But before that resistor it's about 5 volts. So you can see it's raising the duty cycle all the way up until it gets to about 100, and then it just stays pretty much like straight DC. And that's what that's doing. Alright, right here I've basically just got Arduino set up still to read the potentiometer, and I've got that still at 62 kilohertz, which, by the way, I have realized, or I've noticed that if I leave the pin at that setting, it might not function well with other libraries. So I've got this little circuit set up here is basically just a boost circuit, a very crappily thrown together boost circuit, just random components. Random MOSFET I had, IRF 510, 47 microfarad cap, 10K pull down resistor, and essentially I've just got the 5-volt output from the Arduino, which is also lighting the LED, feeding into the gate of the MOSFET. So essentially, if I vary the duty cycle on the output, on the pin output, then it chops up the current going into that inductor different ways, and I can get a peak intensity of around here. Now I could see what that is generally looking like as far as the duty cycle on a little scope if I wanted to, but for example, that's what I'm getting here. I need to play around with the values. Presumably, if I can vary the frequency according to this input voltage, then I'd be able to get this shining a lot brighter, closer to what average Joule thief is capable of. So the question is, what is really going on here? Why can I take this random setup, which will most likely light this 3-volt load better as a blocking oscillator? Why in this setup can I not vary the duty cycle in a way that will yield me much brighter light? Well, I think that's just because I'm limited to a frequency. I've got a set frequency of 62 kilohertz, and I can only vary the duty cycle here. And this is just what I'm getting with these components at this voltage. So with this type of setup, I could change out inductors, change out different values, see what I get. But until I'm actually able to vary the frequency coming out of this pin, then this right here doesn't seem all that efficient. Mixing and matching. And why is that so hard to read? Okay, right here, I have is this little setup. None of this other crap is involved. It's just that transistor, NPN transistor, and I've got it hooked up like a Joule thief using those 3 leads right there from that transformer, which is just another flavor of an exit emergency light or exit sign transformer. You got 277 volts and 120 in your neutral. Here goes another one. Same deal. The lower inductance side. There's my Joule thief. 100K pot on there right now, which is actually shorted out at the moment. And I've got a 1 microfarad capacitor across that pot, but all that's shorted at the moment. So right now I'm running it from this little power supply, which is, it's not registering. It's off now. Not doing anything. I've got this little cheap scope hooked up to the LED load right here, which is a 30 volt load that will begin to just barely illuminate at around 29 volts. With it on right now, it's about a volt or so. Cut it up, see it'll register. So all the way down, it's about a volt. This is what's going on. Drawing a couple 100 milliamps. That's what it looks like going into the LED. The frequency is so low, it's not being picked up right now. I can actually hear it in that transformer right there. It's so low, but as I raise the voltage up, I'll do it like this. So as I increase the voltage, you see now it starts to register a frequency. It's very low. It's under 100 hertz. Now it's up about 100. And I'm getting these peaks of about 35, 30, 33 volts or so, which is what's lighting that strip up. And as I increase the voltage, the frequency goes with it. I'm already about a little over half an amp right now draw. Here really kind of going away, like 4 volts input, half an amp already. So you can see the duty cycle goes up and the frequency goes up. So let's cut that back down. One thing I noticed is for one, you get, when you drive these transformers like that, you can get very high voltage out of these windings. That is until they break down and they arc to each other, and then they become useless, which is what I've done to pretty much all of them. But if you short out the windings, what you get is a little more light and your frequency increases. So, and it's still actually enough to, I just touched it right there. That's still enough to shock the crap out of me. So that's high voltage coming out of there. So I'm going to cut that off. I'm going to twist them together. Now we've got same voltage around a volt or so, but with those shorted, I get a little bit more light, and now my frequency is dancing around, and it's closer to like 500 hertz or so, I could say. So if I crank the voltage up there, as I increase the voltage, I get a more solid duty cycle that increases very slowly along with the frequency. So I'm already at an amp right now, 5.5 volts. So let's undershort that. So now we're running through this pot, which is all the way down, all the way up, highest resistance in this one microfarad capacitor. About 300 milliamps draw, about 6 volts. And you see our frequency has jumped up to about 6.5 kilohertz. Duty cycle is currently at about 16%. Let's see if I can turn that fucker away. So let's see if I can zoom in there a little bit. So that's what we're looking at. So if I start all the way back down at 1 volt or so, where I don't get any light through here because of the way that this pot is. If I turn the pot all the way up, I can get it to a point where it does start to put out light. But let's just leave it all the way down. So what voltage does this thing come on? And it comes on at about, still doesn't register, so it's under 2.5 volts. But at whatever that is, I'm getting this little bit of light. I'm running at about 9 kilohertz, very low duty cycle, getting enough spikes to like that. It's about 60, 70 milliamps. So the relation is, as I cut this up, as I cut the voltage up, you can see my duty cycle starts to increase, then my frequency goes down. So let's put it up to about 12 volts. So this is about 12 volts right here. About 650 milliamp draw. And my duty cycle is about 30%. And I'm getting a peak of about 40 volts positive. And that's more than enough to light this up pretty bright. So basically, the higher I go, the higher the duty cycle increases, and the lower my frequency gets. So I'm going to bump it up till I'm pulling about an amp. So right now I'm pulling an amp, and we're at 18 volts feeding in. And we've got to about a 45% duty cycle, 4.5 kilohertz, and this thing is pretty damn bright. And at that brightness, it's probably about 6 to 7 watts. It's probably not quite 10 watts, but it's getting warm. I can feel it's already getting hot, actually. So at about 12 volts is really what I'm looking at. It's more standard. So about 12 volts or so. That's what I'm looking at. About a 700 milliamp draw, 30% duty cycle. And that's just basically all with the Joule thief configuration. Now, the way that is, the transistor, it's not going to get even warm at all. Even though that's close to 12 watts. It's like 8 watts, something like that. That 8-9 watts is not really, this transistor is not going to feel it. The windings probably going to get slightly warm. I don't feel it. This little resistor down here, that's probably going to be a little warm. Not really. I can feel it just a little bit. The hottest component though is going to be the load here. It's LEDs. These are already getting pretty warm. So as far as like a 12 volt deal using these type of lights, which I've got a few of these strips, I don't know, that's seems a pretty good deal. So let's see, we're about 700 milliamps or so. Given an average based upon 9 volts, I think you're looking at probably like 5 to 6 watts going into that load, and you're pushing about 8 watts into the circuit. So that's not the most efficient at all, going from 12 volts to say 30 something. But I don't know, it's not bad. It's not bad. But at any rate, you know, I tried doing the same thing using the Arduino and pulse modulating either the on time of a MOSFET, or I even used just, you know, regular switching transistors I had, and just fed those from along this LED here, and pulled it down to about closer to like 1.5 volts. But I wasn't able to use that modulation to pulse any inductor I have to get anything similar to that. And I think that's just because I'm not able to vary the frequency on here like I want. I mean, it's got, the pins have a set frequency. I mean, I can change the frequency. I ended up changing the one I was using to closer to 62 kilohertz, which is the highest it'll go. But from there, I've just got a 5 volt signal, which I can, you know, just change the duty cycle on, and that wasn't quite doing it, at least with the values that I had. So back to the freaking Joule thief. Using these transformers I've got, but that right there, I think that's a pretty good deal. That's already getting hot. But I mean, you're basically, you know, you're varying your voltage. It's similar to add a set voltage, varying your base resistance. But you know, you're stuck to a linear relation. So with this right here, I can't modulate the on times independent of the frequency, which is what I would like to be able to do with the Arduino, but I need to figure out how to do that. I don't know if that's possible, to feed an analog signal in one of the analog pins and then actually somehow get that to change the internal frequency of whatever output pin I'm using, vary the actual frequency. But I need to figure that out. A pretty damn powerhouse Joule thief with one of these guys. But damn, was almost able to fix that. Too many little nicks on it. I'll get another one in better condition now. But in the meantime, what do you know? What do you know? That is the end result of that. Just kind of threw it in this box here. So, on low voltage readout. On the back, got the high and low. Kind of see what we're getting. So puts out pretty good light. You can actually see the frequency kind of interacts with that digital readout. So, whereas I've got a shit ton of these damn lighting circuits like these, and I've tried to get most of them just running off the 3.7 volts. Make it easier, so straight from one of those cells I could recharge it with a little module like that, and get a USB output with a little module like that. Which is what I do with a lot of these. Like, here's one, same deal, heavy duty work light type deal, and I've got LED strips that are close to the forward voltage of that cell. So, I'm able to do all that real easily at the lower voltage. And so I got a bunch of those. Like, here's another one. Real handy to use the forward voltage. And then likewise, here's like another example of a little smaller deal, like what that is. That's got the same cell, 3.7 in there. I can use that to test LEDs. So you can see this actually will run one of those strips decently. It's not getting it anywhere near as bright as this one, which just dwarfs it, to be honest. Put it on high. It's just way brighter, and I'm only going to get so much brightness from one of those cells. So, I mean, so many freaking kind of, handy little lights, but to drive that many at that brightness, you just need to get closer to 12 volts or so, which is what I've done here. And at that input, those get hot before long, but they should be all right on that heat sink right there. So basically, another little work light runs from 12 volts instead. Two brightness settings. There you go. Kind of the same deal as what I was doing with this guy over here. But just another one. And forgot. You already know what's in there, but 318 650s in series to get that 12 volts or so. Damn. Since I don't actually have enough little flashlights or like lights, then I have to keep making them. All these fucking LEDs and shit.